Alright, Chemistry, Miss Howard's Chemistry, Unit 8, Chemical Reactions and Balancing Equations, Part 4. Still working with the same teaks. And we're ready for Roman numeral number 4, Types of Chemical Reactions. Okay, the reason we put these and talk about different types of chemical reactions is that it tells us what will react together and what will be produced. Because you don't want to end up wasting time just saying, hey, let's grab this powder and stick them together and see what happens. A lot of times things don't react with each other. So we want to have some kind of idea of what's going to react with each other and what things are produced before we just go in blindly. Okay, so capital letter A, the first type of reaction is a synthesis reaction, where you have two simple substances and they combine into one more complex substance. Okay, so in this case we're using A and X, right? So we have A might be an element or a compound, X might be an element or compound, and they just basically combine into one big chunk. So you have one big compound over on the other side. Synthesis. So you're synthesizing or creating something. So two or more substances combine to form one complex substance. Anytime that you need to pause these videos, so maybe you need more time to write stuff down, just do it, and then you can always turn it back on whenever you're ready. So here we have a great example. Mg is magnesium plus O is oxygen yields MgO. Now, tell me something about that oxygen that's written like it is. Remember oxygen? Help our class find its brain now. It's one of those diatomic molecules, so it should be written as O2. And then we'd have things written properly. Another example would be H2O plus SO3. Alright, H2O, you know what that is. SO3, that's a covalent compound, so you're going to have to use the prefixes when you name it. So how many sulfurs, how many oxygens, and do we ever put mono on the front? So the substance is sulfur trioxide. So if we have water plus sulfur trioxide, we produce H2SO4. You need to know that compound. H2SO4. It starts with H, so it is an acid. What acid do you know that has sulfur or something like it in the name? That would be sulfuric acid. So you have two simpler things, although they're both compounds, they combine into one big chunk and you get H2SO4. Okay, almost, now there are a few things you need to know about these synthesis reactions. Almost all metals will react to form oxides, that means they'll react with oxygen, and sulfides. So most metals will react with oxygen, and most metals will react with sulfur. And oh my gosh! Oxygen and sulfur, if you look on the periodic table, they're in the same group, same family. So it makes sense that if things react with oxygen, they will also react with sulfur. In the same group or family, they have similar chemical properties. Combustion reactions. A combustion reaction is typically a type of synthesis reaction. Not all combustion reactions are synthesis reactions, but many of them are. Combustion reaction means that you combine something with oxygen. Typically, you release a lot of energy in the form of light and heat. It may be a slower process than that, but when we think combustion, we usually think, ooh, we're going to set something on fire. So letter A, the combustion of hydrogen, and in this case, you know it produces a really nice big flame because you can think of that big blimp that caught on fire in the 30s, the Hindenburg. And I'll show you a little video clip of it, or you can Google it or look on YouTube and find it and watch it now. It took all of about 30 seconds for this huge, massive blimp to explode and to burn up. Now, when it did this, it produced water in the explosion, but there was such a tiny amount of water that didn't really help to put anything out. So here's an example, and that's the equation that shows how the Hindenburg in many cases burned. H2 gas plus O2 gas produced a lot of energy and heat in water. And it was in the form of a gas because, it's usually pretty hot. So it's also water vapor in that sense. Okay, B. There's another type of combustion reaction that isn't a synthesis reaction. In this case, it's considered kind of its own reaction. It's the combustion of a hydrocarbon. So when you turn the gas on the stove or when you light the Bunsen burner, you're seeing a combustion reaction of a hydrocarbon. Hydrocarbons only has two elements. Wonder what they are. Hydrogen and carbon. So in this case, you have C3H8. that would be propane, and you combine it with oxygen, and you're going to get as a product CO2 and water. And what's cool about these is you always get carbon dioxide and water. Doesn't matter if it's C3H8 or C4H10, doesn't matter. It's always going to produce carbon dioxide and water, which is kind of handy. Think about this one, C6H12O6. Not a hydrocarbon, but a carbohydrate. That you combine with oxygen, and you still get carbon dioxide and water. Go look back a few pages on your notes and look to where you wrote down the equation for cellular respiration. Okay, second major type of reaction. Okay, we did synthesis reaction, and kind of included in that we also did combustion reaction. So we really covered two already. The next type of reaction is decomposition. It's the opposite of synthesis. So you take one big chunk of a compound, one big clunky compound, and you break it into two simpler pieces. So you have a single compound and it reacts to form two or more simpler substances. Decomposition, it decomposes, it breaks down or breaks apart. There are 6 major things you need to look for to determine whether or not it's a decomposition reaction. There are certain characteristics that you look for, or certain things that typically react. So, if you have a metal carbonate, okay, pick any metal on the periodic table and combine it with CO3. So, let's say Na2CO3 or BeCO3. Okay, so a metal and a carbonate, when you heat them, they're going to form a metal oxide and carbon dioxide. So when you take this metallic carbonate and you heat it, you basically take the carbon dioxide out of it, and so you have a metal oxide and the carbon dioxide. Looks like this. So here we have lithium carbonate, and when we heat it, remember it looks like you just took out the CO2, and we have left over this Li2O, a metal oxide and the carbon dioxide. Second, many of the metal hydroxides, okay, metal hydroxide, like sodium metal and the hydroxide ion, NaOH, when you heat those puppies, they form metal oxides and water. So in this case, it's kind of like you're driving the water out of it. Look at this one. LiOH, and you heat it, and you take out some oxygen and hydrogen enough to form water, and you get Li2O and H2O. Notice that I left blanks there for you. You need to stop a minute and see if you can balance these equations on here. So if we balance these equations, and remember, you want to try and balance these with the pencil. So if you don't have a pencil, go grab one. Pause this and go grab one. So let me find this with my spiffy little pen that, no, it's no longer here. Where is it? Where is it? It's gone. I'm sorry, I would say I'll find it with a pen, but no, it's not going to work. Not going to work. So if we have one Li over here and 2 on this side, start with the metals, then I'm going to put a 2 right here, so I have 2 Li's and 2 Li's. Then I'm going to save the oxygen and the hydrogen, right? Let's say we've got 2 Li's, 2 Li's. That 2 in there applies to the O, and the 2 applies to the H. So we have 2 O's, there's 1, there's 2, and we have 2 H's, and lo and behold, there's 2 H's. So again, if we balance the equation, we know that this is possible. We know that if we take that lithium hydroxide and we heat it, we're going to take some water out of it. Now you say, wait, there's only 1 O and 1 H. Look at your balanced equation. There are enough atoms there for this to occur. Okay, if we have a metal chlorate, ClO3, when heated, it forms a metal chloride and oxygen. So, we're going to give off oxygen gas. It's a way to produce oxygen. So here we have a metal chlorate, lithium chlorate, and we heat it, and it's like, again, we just pop out the oxygen with it. Some acids, when heated, form non-metal oxides in water. Non-metal oxides. So that would mean we'd have something like this. So we have this hydrogen carbonate. Yeah, we call this carbonic acid. And we heat it, and we separate it out. We've got CO2. There is the non-metal carbon oxide, carbon dioxide, and we have water. Okay, some oxides when heated just simply decompose. So if we have mercury oxide, which is a really interesting bright orange powder, and we heat it, which we will not do in class, that's a bad thing, we will get pure mercury and oxygen gas. Pure mercury, guys, if you remind me, I'll take a container out and I'll show you guys the mercury element. It's really pretty amazing. And then we have something called electrolysis. Remember, we're talking about decomposition. Electrolysis is decomposition by running electricity through it. Okay, so we're going to run an electrical current. It's a form of energy. We're going to run it through it, and it's going to decompose it. And let me back up one. That's how you do water. If we take just plain ordinary water and we run electricity, like pull some water out of the tap and run electricity through it, then we will break it down into hydrogen gas and oxygen gas. And again, we're still talking about the same teak, so this part of the notes is over again. Woo!